Hi guys, Sagar here. Hope you understood the previous one. Today we have exercise 1.4. We have only two questions, so let's complete this one. So the first question is we need to prove that the following are irrational. Next one is 1 by root 2. So we are going to prove these irrational numbers are irrational by a contradiction method. So first let us assume that let us assume that 1 by root 2 is rational number is rational. Since 1 by 2 root 2 is rational, 1 by root 2 should be equal to a by b. Here a and b are integers and co-primes. So b by a will be equal to root 2. Here, I mean here, a and b are integers, hence rational. But root 2 is irrational. A rational number cannot be equal to irrational number. So we are going to write that this contradiction arisen DICTION. This contradiction has arisen from our wrong assumption. Therefore, 1 by root 2 is irrational. It was simple, nothing much. So second one we have root 3 plus root 5. Second, root 3 plus root 5. Same, let us assume that it is rational number. So root 3 plus root 5 will be equal to a by b. A and b are integers and co-primes. So let's square on both sides. We will get root 3 plus root 5 whole square is equal to a square by b square. Next, we need to multiply a plus b whole square. We'll get a square plus b square plus 2a into b. That will be root 15 is equal to a square plus b square. 2 root 15 will be equal to a square by b square minus 3 minus 5. Root 15 will be equal to 1 by 2 into a square by b square minus 3 minus 5. Similar to the above sums, we are going to write here 2a, b, 3 and 5 all are integers and hence rational numbers. And root 15 is irrational. An irrational number cannot be equal to a rational number. This contradiction arises from our wrong assumption. Therefore, root 3 plus root 5 is irrational number. Next, third one we have here, that is 6 plus root 2. It is also a very easy sum. Third one, 6 plus root 2. Again, let us assume that it is rational. Therefore, 6 plus root 2 is equal to a by b. A and b are integers and co-primes. This will end in one step. So, root 2 is equal to a by b minus 6. That's it. Here a, b and 6 are rational, root 2 is irrational. A rational can be not equal to irrational number. This contradiction has arisen from wrong assumption. Therefore, 6 plus root 2 is irrational number. Unlike first, second and third, fourth one, which is root 5, we have to prove root 5 is irrational number, which is a little bit hard but easy otherwise. So again, let us assume root 5 is rational. Therefore, root 5 will be equal to a by b, and a comma b are integers and co-primes. Next, root 5 equal to a by b, squaring on both sides. If we square on both sides, we get 5 equal to a square by b square, which is actually equal to, I mean to say, a square equal to 5b square, or b square equal to a square by 5. Here, a square can be divided by 5 and we get an integer. Therefore, 5 is factor of a square. Since 5 is factor of a square, 5 is also factor of a. Since 5 is factor of a, let a equal to 5c. Okay. So again, let us square a square equal to, I mean to say, 25c square. And again, a square will be equal to 5b square, which is 25c square. 5 ones are, 5 5s are, b square equal to 5c square. And now here, c square equal to where? B square by 5. Now 5 is factor of b square also. 5 is factor of b square. That is 5 is factor of b, which is not possible because 5 cannot be a common factor for both a and b, because we said that a and b are co-primes, which is GCD of a and b should be equal to 1. Since we are going to write that since 5 is factor of a and b, which is not possible, this contradiction arises. Again, same, this contradiction has arisen from wrong assumption. Therefore, root 5 is irrational. Okay, this is how you prove root 5. I mean any root 2, root 3, root 5, any root is irrational number. So next, last one, fifth one, we have, what is it? 3 plus 2 root 5. It is similar to the third one. It is also easy. So again, fifth one, 3 plus 2 root 5. Let's assume it is rational. Therefore, 3 plus 2 root 5 will be equal to a by b. A and b are integers and co-primes. So since 3 plus 2 root 5 is equal to a by b, 2 root 5 is equal to a by b minus 3. And root 5 is equal to 1 by 2 into a by b minus 3. Again, we are going to write it as 2, 3, a and b all are integers, hence rational. But root 5 is irrational number. A rational number cannot be equal to irrational number. This contradiction has arisen from wrong assumption. Therefore, our assumption is wrong, and 3 plus 2 root 5 is irrational. That is how you prove different types of numbers. I mean, irrational number or rational plus irrational number or rational into irrational number as irrational numbers. We have the second question of 1.4, which is prove root p plus root q is irrational where p and q are primes. So it is very similar to the third question, which is root 3 plus root 5 of the first, I mean, of the first question. So again, similar to the first bit, let us assume that root p plus root q is rational number. Next, since root p plus root q is rational, root p plus root q is equal to a by b. Similarly, similar to the above questions, a and b are integers and co-primes. So, similar to the third question, squaring on both sides, root p plus root q whole square equal to a square plus a square by b square. Now, we need to apply a plus b whole square. It will be a square plus b square plus 2 into root pq equal to a square by b square. Next, 2 root pq is equal to a square by b square minus p minus q, and root pq will be equal to 1 by 2 into a square by b square minus p minus q. So we are going to write that 2, a, b, p, q all are integers. Even they gave that p and q are integers on the top, I mean primes on the top. So definitely they are rational numbers. And since 2a, b, p, q all are rational numbers, but root pq is a rational number, we are going to write that since irrational is not equal to rational number, it is a contradiction. It is a contradiction to the definition of rational number. This contradiction has arisen from wrong assumption, from a wrong assumption. Therefore, root p plus root q is irrational. Our assumption was it is rational. We proved that it is a wrong assumption, so it is irrational number. It is pretty easy, quite easy. So that's it for exercise 1.4. Hope you understood the two questions, they were easy. You can find the playlist of different exercises of chapter 1 in the description down below. Thank you. Subscribe for more such content.